Hi, welcome to part 2 of lesson 5.5. Now, why is there a part 2? We had originally decided not to do the hypotenuse leg theorem, and even in the previous video, it had said to skip problem number 6. We are actually going to add number 6 back into the extra practice. So yes, you do have to do problem number 6. You still don't have to do problem number 7, unless you want to. So in the original video on page 143, I had asked you guys to cross off that whole page. Now what I need you to do is I need you guys to grab a half sheet of clean paper and glue it on top of page 143. And this is going to be for example number 3. So pause the video until you have done that. And then come back and press play. Now, one of the things that we had skipped was the hypotenuse leg congruence theorem. Now, these examples you already did in the previous video. So let's take a look at theorem 5.9, which is the hypotenuse leg congruence theorem. And it says, if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are going to be congruent. So in order to use the hypotenuse leg theorem, you need to make sure that you have two right angles, that the hypotenuse is congruent, and that the leg is also congruent. So if you have that condition, then the hypotenuse leg theorem can be applied to show that a set of triangles can also be congruent. So like we said, on page 143, you're going to glue this page right there, and you're going to do example number 3 there. So let's take a look at that example. Example 3 is actually a proof. Okay, so here's what we have. They tell me that WY is congruent to XZ, and that WZ is perpendicular to ZY, and that XY is perpendicular to ZY. So the way that the diagram looks, it's really difficult to see what it is that I have in my given. So what I'm going to do is I'm going to split this up. I'm going to draw first triangle WZY. So WZY, and then I'm going to redraw this one right here on this side. So it's a little bit easier to see. And this one's going to be X, Y, and Z. So now we actually get to use and label what we have here. They tell me that WY and XZ are going to be congruent, which means that this side right here and this side right here are going to be congruent based on our given. Now, they also tell me that WZ is going to be perpendicular to ZY. Now, what do you get when you have a set of perpendicular lines? Well, you get a right angle. So because this is a right angle, that's going to imply that this is a right triangle. Now, similarly, we do have the same scenario over here where XY is perpendicular to ZY, therefore making this a right angle. Now, this is not enough for us to be able to apply hypotenuse leg, because in order to apply hypotenuse leg, you need a right triangle, which you do have. You need a hypotenuse, a pair of hypotenuses that are the same and congruent, which they are, but you need a leg. So in this case, where's that leg going to come from? Well, if you notice that ZY and YZ happen to be the same segment, then this side, by the reflexive property of congruence, is going to be congruent to itself. So this is going to be congruent to itself. Hence now we can apply the hypotenuse leg theorem. So let's go ahead and start first with what is our given. Our given is WY is congruent to XZ, and we also have, I'm going to write it below it, WZ is perpendicular to ZY, and we also have XY perpendicular to ZY. Now remember, we are going to be applying the hypotenuse leg theorem. So we need the hypotenuse, a leg, and a right angle. So based on what we see here with WY and XZ, that's going to be my hypotenuse. So now I need to look for the leg, and I need to show that these triangles are going to be right triangles. So this is going to be given. Okay, so now we're going to use this step right here to show that these are going to be right triangles. So because WZ is perpendicular to ZY, we are going to have angle C is a right angle. And for the same reason, angle Y is a right angle. And what is that reason? Well, it's a definition of perpendicular lines. So, definition of perpendicular lines. And it's going to be the same reason for both. Okay, definition of perpendicular lines. So, because these two are now both right angles, by definition, they're both going to be right triangles. So we can state here that triangle WYC and triangle XZY are right triangles. Okay? And this is just the definition of a right triangle. Now, why do we need that? Well, we need that because in order to apply the hypotenuse leg theorem, you need to have right triangles. So, now we look for the leg. Okay, so the leg is going to happen from ZY and YZ. So, here on the fifth step, we're going to have ZY congruent to YZ. And it's the same segment. So that is actually, can't number today, the reflexive property of congruence. And why isn't it not ZY and YZ? Because we have to follow the order of the letters. So ZY congruent to YZ. Okay, the triangles have reflection, so the orientation is not the same. So this is going to give me my leg. Now, with this information, now I can now state that triangle WYZ is going to be congruent to triangle XZY by the hypotenuse leg theorem. And that concludes part 2 of the video lesson for 5.5. Thank you.